Right now we're going to be covering conduction, convection, and radiation, and up first is this awesome thing called convection. So we have water right here. This water all is about the same density, but what if we were to add a heat source to it? So this heat source right here would heat this water up, and now these water particles would be moving more quickly, and they would move further and further apart, like we just saw in the last lesson. They would expand, like this. So what we have here are some hot water particles right here. These particles are moving faster. Thermal expansion has moved them apart, and now, since they are further apart, they are now less dense. And what you guys have told me is that if it's less dense, it's going to want to float up. So if we have water that wants to float up, what's going to fill in its place? So if the hot water's risen up, it's this cold water that's going to fill in from the sides. Okay. Now this hot water went up. Now what's going to happen to the water right here? This water is now going to become hot water, and now this water is going to want to come up. And what we're going to end up with is a cycle where the water is heating up, going up, and the cooler water from the sides is coming down. Now you can see this in your notes. Over here, what we have is less dense hot material, but on the sides we have more dense cool material. And that less dense material, of course, is going to want to come up and around. And that more dense material comes down. You can even see it in the dots. There are a lot more dots over here in the cool material, and the dots are a lot more spread out in the hot material. Now in your notes, what you need to end up writing is hot, less dense material wants to rise, and cool, more dense material wants to sink. And this forms a convection current. The last thing you need to know in your notes is that this happens in liquids and gases. This cannot happen in solids because solids are all locked together and heat will just travel a different way. On to convection. Now conduction, if you take a look at the pictures over here, what we have are hot atoms, and these hot atoms are moving very, very, very quickly. They run into the next atoms over. They heat those atoms up. Now these atoms are hot right here. Finally, those hit those atoms. Now these atoms are hot, and the heat winds up flowing this way by the atoms actually hitting each other. So in our notes, as hot molecules hit each other, heat travels from the hottest area to the cooler areas. This can happen in solids, liquids, and gases because in all three cases, the atoms are all hitting each other, smacking each other, and transferring that kinetic energy. So that is conduction. Lastly, heat travels by radiation. Okay? So in the picture here we have a burning log with little squiggles coming out from it. If you've ever stood by a campfire and noticed that your front is getting a lot more hot than your back, you're noticing that radiation. And if you've ever turned around and then all of a sudden you feel yourself getting warm in the back and your front is cooling off, that's the radiation from that campfire. Also standing in the sun, that is directly radiation from the sun. Okay. Well, hot items emit energy as electromagnetic, or EM, waves. Now these waves are pure energy. Electromagnetic waves are just pure energy. EM radiation can travel through space because it's just a wave, a little packet of pure energy. It doesn't need to bounce. It doesn't matter if there are atoms there. It will go through nothing. And that's what's happening between the sun and the earth. The sun is giving off a lot of this electromagnetic radiation, and it travels a long way in space, and then it arrives with us as nice sunshine here on Earth. But EM radiation can travel through space. So right now, you are using radiation to see. There are little bits of visible light traveling, hitting whatever it is you're looking at, bouncing off and going into your eye. That is how you're able to see something. So your eye is taking advantage of one of the types of electromagnetic radiation. All right? Now the types, they start with the lowest energy, and they happen to be the largest. Okay. The lowest energy ones are huge. There are electromagnetic waves bigger than a city. Okay? But they have very low energy, and those are called radio waves. So a radio, there are radio waves going through you right now, hundreds and thousands of them. So radio waves are all around us, they're going through us, they're so low energy that nothing really stops them. Next are called microwaves. Microwaves are, they're small, they're about maybe the width of your finger. Up next we have infrared radiation. Now you feel infrared whenever you're feeling heat. So if you walk up to a hot stove and you feel that heat, what you're feeling is infrared heat. Okay. Now if something gets more powerful, or excuse me, if the energy level gets a little bit higher than infrared and the wave gets a little bit smaller, that's actually visible light. Visible light is the stuff you see with your eyes, the stuff that goes into your head, and you recognize it as blue, green, yellow, all those colors. So visible light's really important to us for us to be able to see. Now, on the other side, if you get more energetic than visible light, and even smaller than visible light, you end up being ultraviolet. So ultraviolet light would be next. This is more energetic. This is the kind of stuff that comes from the sun and gives you a sunburn, because it's got a lot of energy. It really kind of starts messing you up. Now, even on the other side of ultraviolet, this is some bad stuff. This stuff starts going through you. X-rays, and then the very, very worst, the highest energy and smallest type of EM radiation is a gamma ray. Now, we talk about these more in depth later, but I just want you to know there are different types of EM radiation right now, and that the lowest energy is also the largest, and that's radio waves. Going all the way down to the highest energy is the smallest, tightest waves, and those are gamma rays. And so that's it for the notes.